folks. Happy Wednesday. Hope you're doing all right. Sorry, this change of plans here again. It's been a rough week. Had a good trip, but I got sick. I do have my voice back, but I'm on all sorts of cold meds, and I'm drinking tea instead of coffee, which is really sad. I do miss the coffee, but the tea's really good in my throat, and I can drink a lot. I don't know if I'm drinking more of it, but so a couple things today. We're going to talk about exceptions and modules here from chapters 10 and 11. So these are actually pretty quick, so this will work out pretty nice. And then for project 3, we had that one due the 14th. I'm going to bump that out to the 16th because if anyone wanted to meet, I haven't been able to meet anybody on campus. So I had some questions about that one. So we'll just bump that out to the Wednesday, and I think that'll be okay. So in case we need a little more time on that, should be okay for our Powerball project. And then we'll breeze through exceptions and modules today. And then next week, we'll get into files, talk about project 3 and the final project on Wednesday. Does that sound like a plan? And then we'll hit Thanksgiving break, and then we'll come on back, do inheritance and recursion. Again, we're going to just touch on these topics. We're not going to go super deep because it is a main focus of the 2001 course if you're continuing on. And then week 15, we'll get into plotting and basic graphics. Again, just a high level, nothing super deep. Want to kind of expose you to how these things work. There's no way we can look at all the different plots and that sort of thing, but we'll look at a couple. And then some basic graphical applications are really fun. You can make Python do actual, like have a window that you can click buttons on and that sort of thing. And then instead of our final exam, we will have a final project presentation on the 14th from 11 to 2:30. And then that'll be the end of the semester, believe it or not. So appreciate you bearing with me. And we'll talk about exceptions and modules. So let me fire up PyCharm here. So we've actually seen exceptions before, which is fun. So let's do a new, what week is this? This is week 11. 11 exceptions and modules. Sure. Let's do that. Still, my cat's loving I work in the basement here. All right. So we've seen some of these before. We said like, hey, I want a number is an int of an input. Stuff can't be up on the keyboard. Oh my goodness. I need a door so I can keep them out of the basement, but I don't have that because they're like food and litters down here. Enter a number, and then we run that. And if I give it something that's not a number, like if I spell out 10, we get this exception here. We get this value error. So these are built-in exceptions. Something exceptional happened, a bad thing happened, and the code doesn't know how to deal with it. That's what it's saying here. So what we can do is we can use exceptions on our own to indicate a bad thing happened. So if I were going to write a class like cup here, I think we had cup, and then we would define our init method here, and we might say cup or self dot, I don't know, volume in milliliters, or this is what current volume milliliters, and then we'll have a max, current, and max volume. Again, I always like having the units here anytime we're talking about measurements, so you know specifically what the unit is here. So we probably actually need a way to give it a max volume, right? And we'll assume it's probably empty. So we'll start it at 0. Sure. So we'll give it the max volume, and then we have that. And then we can, add liquid. Sure. Will be a milliliters, liters to add, and we can take our self-current volume and we can increase it by the milliliters to add. Now the problem is, if we go over the max, though, we've now poured tea all over our laps, and hopefully not all over the laptop, because that would be really bad. So we want to avoid that. So what we would do, and what we had in some of these ideas we looked at, is we could just fix it. We could say, hey, if my self dot current volume is greater than my self dot max volume, well, then we could reset it. We could say, hey, let's just set it equal, right? Say, okay, well, it went over the top. We're done here. Sure, and we could return a message. We could return a true or return a false, but it doesn't really fix the problem for us. So what we want to, I mean, it keeps the class in a consistent state, which is good, right? One of the goals of classes is we maintain the integrity of our class, so we're never in an invalid state. This is good, but we didn't communicate back to whoever called add liquid and tell them they did the dumb thing. So what we can do is we can use exceptions instead. We can say, hey, if my self plus that is greater than that, then we can raise I like these value errors. I don't know, I don't know, this would overflow the cup. Sure, why not? Or we could say, hey, if self dot, if milliliters to add is less than 0, we could raise a value error and say can't add negative amount, sure, that sort of thing. And then now we don't need to do any of this other checking. So as soon as an exception is raised here, the code stops running. Exception is raised, the rest of the function is skipped. We just totally skip it, right? So if that happens, we'll never get to this part where we actually go and add it here. That's all. So now if I want, I can use my cup here. I can say, hey, my cup equals a cup, and I'm going to have 10, probably 100 milliliters, why not, right? And then we'll call cup dot add liquid, and let's add 150, and we should get that exception happening here. And now you see we get this nice message. This would overflow the cup. Right, so whatever we put in here shows up in the message, in the value error. Now, if I want to do this based on input here, right, we'll say, hey, how about we get an int, I don't know, to add is going to be an int of an input, how many milliliters you want to add, and then we will add that amount here. Now, it might crash on the user if I enter something too big, but it might not. So if we're dealing with some sort of input and we want to handle this here, now we could add our own checks, and that's fine, but we didn't give them any ways to like get these values back out. That was probably bad. We should probably add some of those gets, like define a get current volume. Let's make this a decent class here, right? Turn self dot current volume, sure. So we can get the current volume, and how about a max as well? Why not? Get max, turn max volume. Okay, so now we can get them out. So we could do the checking here, but if we wanted to, we could handle this exception. So that's the other piece of this, right? With those try except blocks. So what we can do, if we know something might raise an exception, we can put it in a try block. So anything inside the try then will be tried, and if something happens, we put it in an except block. I think, say, except value error as E, I think I want to say. So we'll say, hey, if a value error happens, let's call it E, and we could just print E dot, I think it's just E, might just be E. And then, well, we won't crash here. We just say this would overflow the cup. And it's not crashing the program. So this could all go in some sort of loop then, if we wanted to, and have them like try again, essentially. So, excuse me. All right, so we've got our cup. We're going to add some milliliters, and that could go inside the try. It doesn't really need to go inside the try, but it's fine because we want to do all of that. So we can just say, how about while true? And we'll do this. And if we add the liquid, then we can break the loop and say, okay, we're done here. If we get an exception, we'll print the message, and it comes back up and says, hey, still true, try it again. Right, so how many milli is going to add? 150. Get the overflow lookup. How many do you want to add? 150. Nope, that would overflow lookup. 50, and it's fine, the loop ends, because it was successful. So there's a couple options for how we would want to do that. This is not necessarily the best one, but that's okay. All right, so we can use exceptions in our class to communicate a bad thing happened and force the person who called the method, the function, to deal with it or crash. So it's a very forceful way of saying you did a bad thing rather than just kind of quietly accepting it and fixing it, right? Depending on what it wants to, like, if we just want to overflow, that's okay. We could just set ourselves to max like we had done before, but it's up to however we want the class to behave. Let me see. Excuse me a second. All right, I think we're doing okay. All right, so exceptions with our try and accept. I didn't turn on any of the labs here. I'm sorry. Someone had messaged me about that, and I totally forgot. I'm sorry. Let me turn these on here. Sorry. We are almost done with the labs here, so, and hopefully these are good practice because it'll tell you if you're doing it right or wrong right away, which is nice. So I feel like these are definitely worth the time because it's helps you make sure you're doing it here. This one's a little silly. That's okay. We can do some of these module ones. All right. Almost there. Okay. So when we're dealing with our exceptions, you can have multiple exception handlings. You can catch different kinds of exceptions. So you'd want to start with a very specific type, and you can get more and more generic, or you can just have just except. You don't even have to have a specific type. It'll just handle all exceptions if you want. The first one to handle it, though, will catch it, and then none of the other ones will run. Have some of those. We could raise our own exceptions, right? This raise syntax, those are fine. And then our functions, so that's the idea here. So the last thing we could add to that try catch, you can add a finally block if you want that will always run, just depending on what you want to do here. So especially when you're dealing with files, but we're not there yet. You'd want to close your file, but we're not doing that. And then if you want, you can make your own exception types. Again, it's not too big of a deal here. Not too concerned about that. So dealing with exceptions, right? These try except blocks or using our exceptions to communicate are the main ideas here. And then we can practice this come Monday for lab. I think we'll have time to work on some of those. And then the idea with modules is how do I break up my code into, essentially they're just files, folders and files. So when we go and import things, like we said, hey, I wanted to import random, it's actually going out and grabbing that random file. So let me go see, I'm trying to remember where my Python's installed. I think it's just the Python? No. Files. No, must be in program data. No? Oh my goodness. All right, if I start a new project, it'll tell me. App data local. That's where it is. The app. Oh my goodness. No, C users. Eric. There's app data. Local. Is it Python? Oh my goodness. Local programs Python. Programs Python 310. There we go. So in the library directory, here's the random py file. We're essentially just saying, hey, I want to import this entire file here. And so these are all the things in the Python library. All sorts of cool things we can import here. These are modules, right? A module is just a Python file. So what we could do if we wanted, I could take my cup class here. I'm going to take all of this out, and I'm going to put it in its own module. in its own file. It's the cup. Probably should call it py, sorry. Let me rename that. Refactor rename cup.py. Okay, so this is the cup file now, has the class for cup inside of it, the cup module. So if I want to use cup, I need to import it. So we're going to import. Now it gets a little funny here. So I'm importing cup is the name of the file here. And it says, oh, I don't know what this cup class is now. So there's two different ways you can do imports. So importing the module, we get access to everything. And that's why we had to do like random.randint. So that's the module name, function name. So if I want to use cup, I can say, hey, I want the cup module dot cup class. So this is module name dot class name. So module name dot function or class name is the syntax for that. Gets a little funny here. If you don't like that syntax, and I'm not the biggest fan of it, we can say from cup import cup. Then I can just say my cup is a cup. Because we're being specific, saying, hey, I just want this specific cup class imported out of that file, out of this module. So that's module name and then class name, import class name. Either syntax, whichever one you prefer. So some people say these are a little bit ugly. I like them, but that's okay. Because if you use the module prefix every time, it's very specific. You know which one it's coming from, because it's possible to have two different cups in your file and then or in different modules, and it might get confused. But modules are nice. They give us a nice way to organize all of our code. So in other languages, there's like stricter rules around classes and files and things like that. And I grew up, not grew up. So I started learning first with Java, and Java is very particular, and you get one file per class, and that's their rule. So I've kind of taken to that, and I like that approach because it makes my source control really nice. So I can see, hey, when was the last time this cup file changed? And that would be the last time the class cup changed. If I'm throwing all sorts of different classes into one file, it's perfectly legitimate Python code, but then that file is going to be changed a lot. It might be a little harder for me to track down when was the last time this file changed. So a lot of it's just style preferences when we start working with those. Let's deal with modules. So they just say, hey, this is where I'm getting these from. So you can have different files. You can have your functions defined in one. You can import just your functions and use them. It actually all comes from the module object, which is fun, the sysmodules. Excuse me. Where you can import things from. So Python's pretty cool. And then when it goes to look for modules, it looks for things in the same directory, then anywhere that's in the Python path, and then where Python's installed. So we might not actually have a Python path specified, and that's okay. So it'll just look in your directory where the script is running. So that's why I can just say import cup, because they're both in the same week 11 folder. If I move the file around, it's not going to find it. And that's also why we can import random, because it's checking where Python's installed. Hey, is there something with this module name that I can go find? And then if you want to do that import, you can import more than one if you just want to comma separate as well. Hey, I want to import just these ones, which is fine. And then the last bit here is a little interesting, because if your code, when we run import, it's almost like it's doing a copy paste and saying, hey, we'll just take everything that's in cup and put it in here. So if cup has stuff that's not just a class here, if it has a print, this is the cup module, right? And then I go run my main py here, it's going to say cup module, because as soon as I import cup, it has essentially taken that entire file and put it right in this line. So when I import it, now it's running that print command. So you generally don't want to have things that will run in your modules. Now, if you want to have stuff in there for testing, I would recommend you do actual testing and do unit testing like we looked at here. But if you really want to have something here that if you want to run the cup module, right, I can just run cup and I just get cup module, right, versus running the main file, and I get the main that we were doing over here. You can hide it. So you can say, hey, if this name equals main, then we can print the cup module. So now if I run this one here, this double underscore name is a special variable being used in Python. It's built in, and essentially it's saying, hey, is this the main file that was ran? If this is the main file that was ran, if your name is the main file, then do this code, and I'll get the cup module. But now when I run my main PY file that is importing cup here, when I run it, I don't get the cup module line. So this makes the code only run if this specific Python file was selected to run. Run just on import. Oh, sorry. Oh, I've been pretty good about hitting that mute button, so sorry if I got your ears there a little. I think I caught it. Definitely going to need some more tea soon. So we can kind of hide things there so that they don't run if you want to have it in there with that if name is main. Yeah, this if name is main thing. Checking that. There's some modules. Reloading is weird. I wouldn't worry about that here. Oh, excuse me. Yeah, that's fine. Yeah, and then you can also take modules and put them into folders to make a package. So a package has all of the modules inside of it. So if you want to import, hey, this is specifically the sound package music module, you can import that one, or you could just import all of the game.sound and get all of the things inside of sound. Now to reference it, though, it's a little bit funny because you have package, module, function. And that's okay. It's just going to be a little bit long that way. So depending whatever level you want to import them at here can get interesting that way. Yeah. And then our standard library is awesome. Yeah, all sorts of cool things like the random date and time. We're dealing with date and time, all sorts of fun things. The math module, I think we looked at a little bit. OS we did, or we'll get to when we start doing files. Sys module has a bunch of cool stuff. And then URLs if we're dealing with web requests, which is really fun. All right, awesome. Sorry, my head is really hurting at the moment here. Having a little trouble focusing, but I think that covers some of the basics here for exceptions and modules. When we come back, we can talk more on Monday about exceptions and modules and do a little lab, work with some files. We should be in pretty good shape. That sound okay? Sorry, it's been a weird week. Thanks for your flexibility. And then looking forward to getting back into the regular swing of things. This is so weird. Thanksgiving break seems so early, right? That's the fourth Thursday though, right? Because the first Thursday was yeah, it'll be the 24th. Wow. I guess that's not super early, is it? I don't know. It looks early in the schedule because we still have a Monday, Wednesday in November. But I think we're in pretty good shape. All right, so if you got questions, thoughts, or concerns, let me know. Please reach out. Let me know how I can help. We'll chat more about Project 3 next week. So we did bump out the due date to the 16th, just in case you folks wanted to meet with me. I haven't been able to make it to campus, but I can definitely do remote meetings and things. Should be okay if we want to schedule something, we can chat about it. If not, we'll just keep on cruising, and we'll go from there. Thanks, folks. You take care. See you around.